would have thought it? A groundbreaking new study shows that the Milky Way may be located somewhere completely different than previously assumed. Until now, researchers assumed that we are part of the Laniakea Galaxy Supercluster. However, a new map of the known universe reveals a completely different position, suggesting that our galaxy is part of a megastructure that challenges all cosmological models. If we believe the latest findings of a study from Germany, our picture of the universe could have been wrong so far. If the new maps of the universe are correct, then our galaxy group is located somewhere entirely different than previously thought. Until now, our Milky Way was identified as part of the Laniakea Galaxy Group, but the latest measurements and mappings have turned these assumptions upside down. According to this new data, our Milky Way could belong to the much larger Shapley Supercluster, a collection of galaxies larger than anything we can imagine. The Shapley Supercluster is one of the largest known structures in the universe, and its sheer size and complexity defy previous cosmological models. Similar to the ancient galaxies discovered by the James Webb Telescope, the Shapley Supercluster does not fit into the current cosmological worldview of the Big Bang, the expansion of the universe, and its homogeneity. In a homogeneous universe, structures of this size should not exist. Additionally, the cluster is too old to support the Big Bang theory, as a structure of this magnitude could never have formed in the time our universe has supposedly existed. The universe appears to function like a gigantic whirlpool, with gravity acting as a massive attractor. Until now, science has depicted the universe as linear, with objects evenly distributed and forces acting uniformly. However, this picture is crumbling, and the new study from Germany could play a significant role in reshaping our understanding of cosmology. An international research team led by the Leibniz Institute for Astrophysics in Potsdam used a novel cosmographic representation method to analyze the movements of 56,000 galaxies, resulting in the most up-to-date map of the local universe. This map reveals impressive new cosmic structures, including an incredible large-scale network of galaxy superclusters and hints of forces and structures we do not yet understand. The map has also led to a reclassification of our galaxy within the known universe. Galaxies do not move randomly. They follow invisible currents and the attractive and repulsive forces of matter and energy. Massive large-scale structures like the Laniakea Galaxy Group and the Shapley Supercluster exert gravitational forces, collecting more matter over time. Scientists refer to these gravitational centers as attractors. The absolute giant among these megastructures is the 1.3 billion light-year-long Sloan Great Wall, a collection of countless galaxies, cosmic dust, and gas clouds. Counteracting these mass accumulations are voids, gigantic empty spaces, and a mysterious large-scale structure discovered in 2017 called the Dipole repeller, which pushes galaxies away from itself, directing them toward great attractors. This creates dynamics akin to cosmic ocean currents. The Milky Way is surrounded by 17 megastructures, each exerting tremendous forces in the universe. The interactions and overlaps of these structures are difficult to understand, complicating the previous classification of our galaxy's exact position. Observing galaxies from Earth is a challenge, as telescopes must look through our own galaxy and past other galaxies, which overlay the image. Until now, it has been difficult to predict where our galaxy is located within these mass accumulations. The Cosmic Flows Force Survey is the latest approach to providing clarity. Using advanced algorithms, astronomers analyze the proper motions of 56,000 galaxies, revealing patterns that provide details about the location and catchment areas of large structures. This process can be compared to observing ocean currents, where surface movements are influenced by deeper, more complex dynamics. Similarly, the visible movements of galaxies are part of a complex system that we are only beginning to understand. Our universe is likely the largest ocean we can imagine, with attractors and repellers creating a dynamic interplay. This realization is exciting but also presents challenges for researchers, as the universe appears more chaotic and wild on a large scale than previously thought. Our scientific theories and approaches are struggling to keep up with these complexities. Mapping the universe has brought many surprises, from ancient sky maps like the Nebra sky disk to modern star maps showing billions of stars. However, instead of generating more knowledge, new insights often raise more questions. Inaccuracies in observations, measurement errors, and incomplete data further complicate our understanding. Galaxies themselves are chaotic and irregular, making them poor indicators of the distribution of matter within structures. Their movements are influenced by the expansion of the universe, gravity, and other forces, making precise measurements difficult. Cosmologists often rely on probability-based values rather than concrete facts, which has made classifying our own galaxy a challenge. Thanks to the latest algorithms, researchers now have the most reliable picture of the large-scale distribution of matter in the known universe. The new maps suggest that the Laniakea Supercluster, once thought to include our Milky Way, may not exist as a distinct structure. Instead, it appears to be an appendix of the much larger Shapley Supercluster. Even more surprising is the emergence of another megastructure from the Sloan Great Wall region, which breaks all previous cosmological rules. This wall, composed of hundreds of thousands of galaxies and spanning about 1,000 trillion cubic light-years, indicates that our universe may be far larger than previously assumed. The dominant attractors in our universe, such as the Shapley Supercluster and the Sloan Great Wall, push researchers and computers to their limits. These structures exceed our capacity for data processing and imagination, much like trying to predict the effects of the entire Pacific Ocean on the coast of Hawaii. While the new study from Potsdam has provided groundbreaking insights, even more precise calculations and maps will be needed in the future. Hopes are now pinned on the ESA's Euclid Telescope and the Vera Rubin Observatory, which aim to provide significantly improved mappings of the sky. Quantum computers may also soon help fill the gaps in our understanding of the universe. Press the subscribe button now. The best videos are yet to come.